continue. Okay, so I'm recording this so that in case I can share it. Last week I was able to record some extent. All right, so basically any problem that we have, we should be able to write an algorithm for it. The algorithm is not the program. The algorithm is not the program. The program, like for example, the software we are using now is a Zoom program. And with the Zoom program, it solves a certain problem. It allows us to do video conferencing. Are you okay? So you can see me. It allows sharing of documentation and resource. Okay, so you need to think that way. The student has to think that way. All right, I'm expecting you to think that way. Okay, and if you don't think that way, then of course I'm going to fail you for this course. Start thinking about how to solve a problem, how to calculate some X and Y value, but not in your usual mathematical way, but you making use of what? Variables, okay? But then you're able to assign values to the variables. When you assign the values to the variables, we are able to then, the computer stores that value in the memory of the computer. And that is what really happens in the background. But at the end of the day, every program you run on your computer, they are variables. It's all the values are stored somewhere in memory. Okay, and the values don't remain the same. They keep changing. So your knowledge in algebra is very vital if you want to understand programming. Excuse me. So we talked about variables in our last lecture, and we said there are two types of variables that you can have. You can have the scalar variable, and you can have like three. Multi-dimensional variable is also there. That's the one I wanted to talk about, and I think it wasn't coming to my mind. There is the scalar variable, there's the array variable, and then we have the multi-dimensional variable. Now it's like just saying, when you really look at it, it's like saying a single value, vectors, and then matrices. Another way of saying this. But the sad truth about most students that they may not understand the vector itself. Now, when you don't understand the vector, how do you go ahead and talk about something else that relates to it? So I encourage all of you that there's something that you shouldn't run away from. If you're going to be an engineer, you shouldn't run away from math. Everywhere you go, it will hunt you. Some of the so you just embrace it. It's okay. Because now everywhere, as you go to level 304, it's the same thing that is following you. Okay. So variables, if you hear and you don't understand it, please, I'm just begging you, try and understand it. It's very vital. Now, you see on the screen, scope of the variable. So the scope is like, how far can I go with this? Okay, if you want to say it in your own words. The scope is like, the level, are you okay? Or let me just say the extent to which you are going, are you okay, with something that you are doing. So for variables too, there are certain places where you cannot access them. That's because when we write programs, we actually put down the name of the variable and we expect to find out what the value is in the program. Are you okay? So in the program, you can be having a variable and then just call it. Are you okay? You call it from any line of code and then find out, okay, what is the value in this variable at this time? So we look at the scope of the variable. We also look at the lifetime of the variable. Why are we talking about scope and all that? When you write a program, there's lots of lines of code that you write, okay? You have a whole project containing so many codes. Some of the codes are all, are grouped as in a construct. Are you okay? In different, there are several procedures that go under one project. Are you okay? So the whole project is so many files and codes that are arranged. Okay, so we need to understand that it's not every part of the project that you can assess the value. Are you okay? It's not every part of the project. It's just like the way we Christians talk about the Holy Spirit being everywhere, that kind of thing. All right, but not everybody has the Holy Spirit with him. The same thing with the variable. It's not everywhere you are in the project that you can assess a value for the variable. Okay. So or let me just say the presence of God being everywhere, God being omnipresent. That concept, that's how variables are. We can have a scope, you can have a lifetime. Once you talk about life, think about dying, the death. Are you okay? So the variable can die. Are you okay? So you can have, we have what we call die dump in PHP programming, so which is another language. We have what we call the die dump. So it's like you can kill a variable. Are you okay? The word die is used in PHP, and I always ask myself, why do they use such a a word? But it tells you that variables are like living. You can look at them like as if they are living things or something like that. But obviously, it's because their value changes with time. Okay, so that is how it is. I'm trying to show you my Microsoft screen, but anyway, it will come up. I'm sure one of you see it. Let me just go on like that. So the scope of a variable scope is determined by where you declare it. It is determined by where you declare it. So where you declare a variable determines its scope. Okay. Take it like that for now. You understand why it's like that when you actually see a code, an actual code. So when you declare a variable within a procedure, only code within that procedure can access or change. I was just telling someone that we're cooking, okay? All right. When you're actually doing cooking, all right, one of the things you do is you may grind. Are you okay? So when you're actually doing something like you're playing tennis, I mean, we don't grind anything when you play tennis. When you see someone grinding a table tennis ball, and there's something wrong with the person. Are you okay? He's totally gone bonkers. So where you declare, and when you declare a variable within a certain procedure, that is where it's available. Are you okay to you? So that's one thing about scope of a variable. So we talk about local scope. Come here, say hello. Say hello to everyone. Say hello. That's my friend, okay? He's wearing the Spider-Man jacket. I don't know if you can see it. Show them. Yeah, it's called, yeah, he's the man. Okay. Yeah. Okay, so we can have local scope and then we can have global scope. You know, once you have local scope, so sometimes when you go into an exam, like I keep saying, it's not everything you have to chew in your head. Once you see local, there's got to be. Yes, you can go ahead and have the biscuit. He knows I'm so busy. Local scope, and then we can have global scope of a global variable. Is okay. So the local scopes are, we talk about local scope when we refer to the procedure, particular procedure, and then what. So the procedure is something that you do. Let me just say, procedure will be like brushing your teeth. Are you okay? The brushing of your teeth procedure is something that happens, you know, in the morning, 2 minutes, done. Just think about procedures that way. Now, if you declare a variable outside the procedure, you make it recognizable to all the procedures in your script, as if the procedure kind of like begins and ends, and if you do anything outside it, then it becomes available. No, everybody can hear you. Please tone down, okay? They are not saying anything. Please, guys, better say hello to this boy before he doesn't believe I'm talking to you. Anyway, so we can talk about, like I said, the lifetime of variables, so that the variable can be destroyed. Are you okay? The variable can be destroyed. Okay, so there you go. The lifetime of a script level variable extends from the time it is declared, okay, until the time the script finished running. So once you finish running your scripts, which is like the program you've written, that's it. Some variables, they don't become available anymore. Is that okay? All right, so at procedure level, a variable exists only as long it exists. When the procedure exits, the variable is destroyed. You get it? So the variable becomes, you know, it's dead. It's dead, like as if a human being is dead. All right. So that is how it works. Okay. It can lose its value, and then you like you using your phone. Okay, anytime you switch off the phone, you clear the memory. So that's why some phones, I told you before that in some phones you had to restart it. Why? Because the variables have now loaded in, because you open so many programs and they all having values. Are you okay? All right, so you can have the local variables with the same name in several different procedures. Okay, so what does it mean? I can say wash, but we all know that wash, when it comes to washing clothes, is a bit different from washing the car. But washing car is a different procedure compared to washing clothes. Okay, so that is how variables are. You need to be in the spirit. Okay, when we're teaching some of these things, just try and come to, because we will do it, and we will do a practical. I'm sure this weekend we are doing a practical. So pay attention. If you're not careful, you understand the theory, you understand the practical. So please follow me, make your own notes, and then take it as they are. Okay, we assign values to variables. I think this is what we did last week. So what I'm doing is that I'm only recapping some of the things that we've already talked about. All right. So the variable is on the left side of the expression, and the value you want to assign to the variable is on the right. So if you remember, we did something like a equal to 200. So the value is 200, and then equal sign is the assignment operator. A is the variable. Are you okay? All right. So example is what you are seeing on the screen now. B equal to 200. Okay. Speed 1 equal to 20. That means that we are giving 20 to the variable called speed 1. This is a very good variable name because it started with a capital. Normally you want to start with a small letter. So B equal to 200, speed 1 equal to 20. Normally when you type in PowerPoint, it appears, it always forces you to have a capital beginning. I mean, it's trying to do some grammar check for you. All right, that's another example. T equal to T plus 1. It also means T equal to T plus 1. Just as we did in the class where we're doing I equal to I plus 1. Okay, so this is also possible to do, to have. Okay, so but then your interpretation of these three lines here is that we are trying to assign a value. Are you okay? That is your interpretation. We are trying to assign a value, everything that you see here. Okay, so that is basically it. All right, so then we talk about the array variables. Okay, a variable containing a single value, a variable containing so many variables, so many values. Are you okay? That we call an array variable. I hope you are listening to me. Pay attention. Okay, so you can create a variable that contains a series of values. We call that an array variable. I think I talked about that last week. I'm talking about it again. Okay, so there you go. Array variables and scalar variables are declared in the same way. So, but then with array variables, you have to bring brackets. You open brackets, you close bracket. Okay, and then you have the size of the array inside it. What I'm talking about, I talked about last week. I'm only repeating it. Is that okay? So take it as a bonus for you. Those who didn't come for the class, I mean, I don't mind doing it because it does get sometimes a bit difficult for you to understand. So here, this is a Visual Basic Code. Here we are dimensioning, or we are declaring a variable to store how many values. This question should go to, if Miss Paulina, if you are here, try and answer this for me, or who else should know about it? Whoever came for last week's lecture. How many objects, how many items do we have in this declaration? How many items are we storing? How many values are inside the variable A, which is supposed to be an array variable? How many values are in there?
11.
Okay, obviously it's on the screen, isn't it? Okay, all right. So although the number shown in the parentheses is 10, all arrays in English are zero based to actually contain 11. I think I should have asked you this question. I shouldn't have. Okay, but I hope you understand it though. Okay, so we talked about it last week. So AR11 contains 12 elements. So we always add one to the side. Okay, so that is the way to do it. All right, to get the number of items in an array, you dimension it such a way that the size of the array plus one tells you the number of items to be kept in there. So here are examples of assignment of a value to a particular index in the array. So we are assigning these numbers 2, 5, 6, 3, 2, 4 to the 0 index and then 100. Okay, so there you go. We are doing an assignment. How do we get the value in the array? Down here, we are trying to get the value in the array. So this is the 9th index. Or the, well, actually 0 is the first index. Then 8 is what? The 8th index is actually the 9th item. So this is the only tricky thing about indexes in Visual Basic. Yeah, zero based. Okay, the application of arrays and multi-dimensional arrays, as we'll talk about multi-dimensional arrays, is that they look similar to the math concept of vectors and then matrices. Is that okay? So here you can see that we have a 3 by 3 plus a 3 by 3 vector. That will give you a 3 by 3 vector. Is that okay? So we are going to create 3 arrays using Visual Basic. The DIM keyword, okay, open sesame, those who didn't attend international schools where they were teaching about Alibaba will never understand the keyword. So the keyword DIM tells the computer that you want to create a certain variable in memory. It should be called ARR1 and you should store 3 items. AR2 also, that's the same. AR3 same. Okay, so here the only variant is that we could have actually indicated the type of value we want to store there, what we call the data type. So as integer, as could have done double later. In fact, today we're going to talk about this before we go. Data types, okay. So we are storing real numbers, we are storing integers here, okay. All right, great. So basically that is what we're doing in this assignment. Last week we talked about the object variable, an object variable. So an object variable example will be a control that we use in the programming interface. So when you design a program, there's what we call the graphical user interface. Everybody who's done some basic IT understands this. All of you have done some basic IT. So the object here is TSTARR11. And then we're trying to get the test property of that object. And then we are assigning the value to an array at index 0. And 0 is the first place, the first index, the first position in the array. All right, so similarly here, we're getting the object is a bit different. It's an array. Let me just say it's a position row 1, column 2 in the array, and we are trying to get a test for that. Okay, so let's assume we've arranged a lot of text boxes on our user interface and we are trying to get value for it. We will do a practical, you understand this better. This is what we mean what we do when we actually try to implement vectors, okay, in using programming languages. We get a value from the user via this side of the program. Here we're getting values from the user. Here we are putting them into the array. Okay, so here we are putting them in the array. So we've put 4. Okay, let's see the first line. Okay, AR1. Okay, so the first 2 lines, the arrays are the same. Okay, So here, these two